Dr. Romano, professor of organic chemistry here at Romano Scientific and the creator of the Orgoman products and the DAT Destroyer books. I'd like to go over a general chemistry question today with you that has got multiple concepts, meaning that this one video can encompass 4 or 5 questions that could possibly land on the exam. Let's have a look. Don't worry about the calculation. We can do it with a calculator. On the DAT, the numbers will be much nicer. On the Destroyer, they'll be nicer as well. But let's make sure we understand the concepts. We have an unknown gas that was colorless, and it had the molecular formula XOF3. And we found that the mass was 0.472 grams, and we had 4.54 to the minus 3 moles of the gas. Part A, we're going to find the molecular weight of the compound, and we're going to identify X. One of the key formulas in general chemistry that you need to never forget is the molecular weight is grams over the moles. Well, if you knew that, it's an easy question. We know the grams and we know the moles, and we now know the mass is 104 grams. Well, if the mass is 104, and we subtracted the mass of the oxygen, which is 16, there was 3 fluorines that weigh 19 apiece. The difference of all that gives you 31. We look up 31 in the periodic table, and we see it's phosphorus. That's simple. Part B is a great practice question on the molecular geometry, to draw it. Well, the way I would do it, and we got a whole bunch of these in the Destroyer, is we got to find the number of valence electrons. Phosphorus is in group 15, but think of it as group 5. That's the way we used to do it. Think of phosphorus as group 5. Oxygen is in group 16, but think of it as group 6, which means it's got 6 valence electrons. Fluorine is in group 17, think of it as group 7, and there's 3 of them as 21. When you add up all these numbers, you get 32 valence electrons. Easy enough. You put the phosphorus, which is the more electronegative in the middle, put all the fluorines with a single bond around you. Oxygen loves to form a double bond with things like phosphorus and sulfur. So let's try to put in a double bond. So if I double bond this, and then you put in the outer valence electrons, everyone gets 8 on the outside. So 8, 8, 8, and 8. And you can see that gives you the 32. And if you notice, phosphorus has disobeyed the octet rule. Always a question that they can ask. So notice phosphorus has more than 8. All right, as you can see, this would be a tetrahedral molecular geometry, and we have 4 areas of space, meaning that that phosphorus is sp3. All possible questions that can land. And then, just to spice it up, name it 2 different ways. Well, this could be phosphorus oxyfluoride. Phosphorus oxyfluoride, or I can call this phosphorus trifluoride oxide. And that's the one I prefer because it gives you more of an understanding to show that there's really 3 fluorines. Here it sort of hides the 3 fluorines. So phosphorus trifluoride oxide would probably be the best IUPAC name. I hope this gives you some great understanding of how to do a really challenging type of a question that has multiple concepts. All right, good day to you, and I'll see you in our Facebook study group. Bye-bye.